So hi guys, welcome to lesson 14, and you can check our YouTube channel for past lesson recordings. So today's subject is math, biology, and pop culture. We'll first start with biology. We're gonna talk about evolution and natural selection. Okay, so last time we talked about all living organisms are divided into 5 kingdoms, which is the animal, plant, fungi, prokaryotes, and prototists. And there are also like small groups within the kingdoms. We talked about 4 small groups in the animal kingdom, which is the annelids, mollusks, arthropods, and vertebrates. So annelids are soft-bodied animals with segments on it. A segment, you can think of it as a little ring that divides their body into small parts. And mollusks are soft-bodied animals, and they lived in wet areas or water, but like they do not have segments. And arthropods are animals with an exoskeleton. Exoskeleton, you can think of it as a hard shell outside its body that protects the animal. And finally, vertebrates. Vertebrates are animals with a spine, or you can call it a backbone. Human are vertebrates too. And these are some examples of those animals. On the top left, right? Yeah. It's a earthworm. You can see like those little circles, those little rings on his body. Those are segments. So a earthworm is a annelid. And on top right, the first one is a jellyfish, and the other one is a snail. They are both mollusks. And on the bottom left, it's a crab. And a crab, you can see like those hard shells outside its body, right? So a crab is a arthropod. And finally, these 5 animals, they are all vertebrates. So let's moving on to today's topic. Today we're going to talk about evolution and natural selection. So, have you guys ever think about the question that why there are so many kinds of species on Earth? Like, why are they so different? Why they look so different? Why they have different structures? And like, why like some species may not exist anymore? Like, for example, the dinosaurs. And why like how did human occur? So to understand these questions, we first need to know like what causes species to change over time. It is the natural selection. So natural selection means organisms better adapted to their environment tend to survive and reproduce more offspring. So like let's look at 2 examples. Like it might like let you understand better. So the first example it's about worms. So there are now 2 kinds of worms. One is green and one is purple. So they both live on a big grassland. So now imagine like you are a big bird. You are a big bird that you hunt on these worms and you eat them for food. So imagine like when you come to the grassland, do you see the green worm first or do you see the purple one first? Like you must see the purple one first, right? So this is like natural selection because over time more and more purple worms got eaten because they are like more easier to see, and more green worms survived, and more green worms, they reproduce with each other and they produce more green worms. For the second example, there are two giraffes. Giraffes, they eat leaves on a top tree, on a tall tree, on the top of a tall tree. So like you notice the giraffe on the right, it is very tall and it has long necks. So this giraffe, it is easier for him to eat the leaves, and so it gets food. It gets enough food to live. But for the giraffe on the left, it is very short and it has very short neck, so it cannot reach that high, so it does not get food, it dies. So these two examples basically just explains what natural selection is, right? It's just like if you can survive better in the environment, then you survive and you reproduce more. But like if you cannot survive, you die. So natural selection, it's when natural selection happens over a long period of time, it's evolution. So evolution is the change in heritable characteristics of populations over time. So the first thing we need to know is, what is heritable characteristics? Heritable characteristics are like it's in your gene. Like you can think of it as you were born with this character. For example, like your skin color, your hair color, your eye color, those are all your heritable characteristics, and it's from your parents, right? And also, like some people may have curly hair and some people may have straight hair. Those are all heritable characteristics. However, like on the right, this girl, she has green and purple, green and pink hair. But however, this hair color is not heritable. It's inheritable because those hair colors are not like are not like she does not born with
They're
those
not
hair
natural.
colors. She dyed her hair using like chemicals, using colors. So her babies will not have those hair colors. And also another example is like maybe you have a scar on your skin. Those scars are not like born with you. You get it like maybe when you're 10, when you're 12, sometime. So like it is not born with you, so it's not inheritable. Sorry, it's not heritable. So there's also like a very important person we must know. He's called Charles Darwin. Charles Darwin was a British naturalist, and he came up with the idea of theory of evolution, which we just talked about. So Darwin believes that like species changes over time, and new species form, and they all share a common ancestor. So this is all for today. Like, hope you enjoyed this class. And next time we're gonna talk about the ecosystem. So see you guys next time. Bye.
No, not by next topic.
Oh yeah, next topic. I just ended it.
No, you can still share the slides.
Oh, okay. So next one, wait, who's next one?
Okay, guys, next we'll be talking about math, and today in math we'll be talking about limits. So if you guys know functions, right? Functions like x squared make like the parabola in the middle of that graph that you would see, right? Normally functions are continuous, but sometimes like the graph you guys can see on the top left of the slide are broken. They're like not continuous, right? This is when limits get really useful because when there's a break in the function, essentially, you won't know what the value is, like the y value is at that area because there essentially is no y value because the function is broken. So essentially what limits are saying is like what would the value be at the broken area if we were to get as close to it as possible. So in the graph in the top left, you see that there are two breaks, one at A and one at B. So just by looking at it, you can't actually tell what the Y value is at A and B, but you can use limits to find it out. Now, for this particular graph, you can kind of tell that um, at A, they're going up towards just like going straight up, right? So therefore, the limit is going to infinity because if you were to forever go up, you would reach infinity. That's why next to the graph, you can see that if we approach A from either the left or the right, like either arrow, we will reach, we will approach infinity. We'll never get to infinity because infinity is like not an actual value you can get to. Like there is no infinity in this world, but we'll get to infinity, like as close to infinity as possible. However, at B, you see that the two arrows are pointing in opposite directions. One of them is pointing up towards infinity, and the other one's pointing down towards negative infinity. So, what value are we approaching then? Well, the answer is DNE, which stands for does not exist. There is no value when x equals b, because when x equals b, y you can't get a y value. It's like impossible because your graph is going in two different directions. You kind of get two different values at the same x value. So it's impossible to have a y value at b. Can we go to the next slide? So yeah, so how do you tell if there is no value? Like, how do you tell when it's D and E? That is when you look at the graph and you look at what we're approaching from the left and what we're approaching from the right. Because whenever we have a discontinuity, like a break in the graph, there's always a way to approach the broken area from the left and from the right. If we can approach the same y value from both the left and the right, then we have a possible like value for the limit. But if we can't, then it does not exist. So in this case, you can see that as we approach 2 from the left, we get positive infinity, but as we approach 2 from the right, we get negative infinity. So therefore, there is no y value when x equals 2 because the you don't approach the same value from both sides. And usually when you see limits, if there's like a minus sign to the top right of the number. I don't know if you guys can see it properly. But under limit, it says limit as x goes to 2 and there's a minus sign. That means we're approaching from the left. And then if there's a plus sign, then that means we're approaching from the right. Okay, come to the next slide. Okay, so these are just like a couple more examples that are not gonna lie a bit complicated, but they kind of just show all these examples kind of just show the same thing. These are like limits as x goes to infinity. So realistically, if we have just like a regular polynomial, as you can see at the top, like 3x squared minus 2x over 4x squared plus 1, we can plug in a value to get an answer, right? But if we set x to going to infinity, like we can't physically say x equals infinity, because if we say x equals infinity, then you wouldn't actually have an answer, because infinity divided by infinity is not an actual value. We can only say as x approaches infinity. That's why we have to use the limit. We can never say x equals infinity, because then we'll have some math problems. So we can only say as the limit as x approaches infinity. So here, for the part, for example, A, you see that it's like it's saying the limit as x approaches negative infinity. Oh, and you have to answer what will that polynomial, like what's the answer to that polynomial? And for problems like these, they're actually quite simple to solve. You kind of just look at the largest like x value in the polynomial. So here, the largest one is x squared, right? So next to x squared, we can see that it has, there's a 3 on the top and a 4 on the bottom. And therefore, we know the answer is 3/4 because infinity squared is technically bigger than infinity, I guess. So we don't really have to consider the minus 2x or the plus 1, because 4 times infinity squared, essentially plus 1, is not going to change anything, because plus 1 is insignificant when you're considering infinity. And just to recap, just to like remind you guys, we're not actually setting x to infinity. We're just saying the limit as x goes to infinity. Okay, next slide. Oh, and for this one, it just another like short reminder is that when you guys square root stuff, you have to consider both plus and minus, because the square root of 4 is not just 2. The square root of 4 can also be negative 2. So you guys have to like consider that whenever you guys see a square root. Like yeah, if you look at the top right of the slide, it shows you that you have to take the absolute value of x, which gives you either positive or negative x when you square root x squared. And that's about it for math. And then we're going to move on to pop culture next. Xinglong, can you do pop culture? Hello, Xinglong, are you there? Can you do pop culture? Okay, you know what? I'll do pop culture then. Okay, so today in pop culture, we're going to be doing the Olympics.
Hi. Um, yeah. Am I
Yeah,
am
you
I
can do it.
teaching? Okay. Share the screen.
No, no, you don't need to share screen. It's right on the screen already. Just do the slides.
Okay, okay. Um, but I don't think this slide. Oh, no, I can do this. Um, so the history and the overview of Olympics, the or originated in the ancient Greece, which is 776 BC, and the modern Olympic Games started in 1886, hosted by the Athens. And the Summer Olympics and the Winter Olympics have every 4 years they host one. And Okay, and this is the summer versus winter Olympics. The Summer Olympics have swimming, rowing, water polo, track and field. And the Winter Olympics have the skiing, ice hockey, snowboarding, and the figure skating. This is the pictures. And the hosts, okay, this is the host. The hosts of the Olympics are held at a city or a country around the world. Example of the Tokyo 2020 and Beijing 2008. The tradition of the Olympics is 5 Olympics rings symbolize the 5 inhabited continents: Africa, America, Asia, Europe, and Oceania. Beginning of the ceremony. Olympic flame is lit and remains lit until end of the ceremony. And this is the great Olympians. This is the Michael Phelps. He is the swimmer, and Usain Bolt. He is the sprinter.
And fun fact, guys, this year the Olympics are going to happen this summer. So if you guys want to watch it, you guys can watch the Olympics this summer, and they're being held in Paris this year.
Yeah, okay, sure.
Okay. Thank you all for coming. And if you guys don't have any more questions, then can you guys, we would appreciate it if you can fill out this feedback form. And that's all for today. Thank you guys.